Hello all, welcome to the Engine channel. In today's video, let's have an approach regarding the smart relay Zelio from the manufacturer Schneider Electric. Basically, the subject is specifically regarding for the analog input, where we're gonna connect a potentiometer. Could be useful if you need to do some program or some application where you need to adjust some set point or some level, some adjust, something like that, using a potentiometer. So then you can rotate, increase or decrease the resistance, and then we have the set point, the objective that you need to achieve, the adjustment that you need to achieve. Okay, so let's move on. So this is the models that have the analog input available. So basically, regarding the supply, the power supply of the models, basically we have 4 different power supplies, and will be important because only for the DC models that use 12 volts DC and 24 volts DC have the analog input available. So as you can see, for the model of 12 volts with 26 IOs, we have 6 analog inputs, and for the 24 volts DC, we have basically 2 models, one more compact and other one with more IOs. The small one have only 10 IOs and the big one have 26. So for these models we have the analog input available. Differently of the AC, that even for 24 volts AC and for 100 to 24 volts AC we don't have any analog input available. Okay, the reference of each model is here. So basically the current version that is in production by Schneider Electric is SR3. However, there is the previous version that is SR2. So for the SR2 version, we already have the same option to have this analog input available. Okay. So here we have the 2 models, one with 10 IOs and other one with 26 IOs, correct? Yes, 26 IO, as you can see here. So here is the location of the analog inputs. One thing that is very important to emphasize is, as per the manual, this is mixed input. Means that they can be digital or analog. Let's say that they are hybrid. So we can select if you want to use as a digital input or analog input. So for the compact model with 10 IOs, we have 4 analog input available, starting by IB, IC, ID, and IE. So this can be analog or 24 volts DC. Means that analog or digital. Okay, and then for the 26 IO models, Zelio models, smart relay models, we have more analog inputs, starting for IB, IC, ID, IE, IF, and IG. So total is 6 analog inputs. Okay, so as we can see here, 6 analog inputs. Okay, so same characteristic, analog or 24 volts DC. Perfect. So here there is the models. So SR3, B10, and then we have the 2 options, that is 12 or 24 volts DC, and the same for the SR3B26, that could be 12 or 24 volts DC. Okay, moving on. So here is how to connect the analog input. So when you look for the product datasheet, we have the example how to make the connection. As you can see, we have the option to use the potentiometer, and here we have other such of sensor connected to the analog input. So basically there is some reference here. So basic, the number one is here is the fuse for protect the circuit. And then number two is the analog sensor or analog transmitter that is in the second example here. And then for number three, that is the potentiometer that we will show here. The recommended value is 2.2 kilo ohms with a power dissipation power need to be half watts. The maximum resistance could be 10 kilo ohms, and have the other details regarding for the size of the cable in the example number 2 that cannot be more than 10 meters. And as well we have the analog inputs according to Zelio Logic Smart Relay. So we need to check regarding which models of Zelio Logic Smart Relay we have for SR2 as well here, the previous version, and the SR3, the current version. And as well, the last information is regarding the voltage that will be possible to use 0 to 10 volts DC analog. Okay. So here is a zoom where we can see how we make the connection with the 3 wires of the potentiometer and the recommended values that I already mentioned before. Then we have here the details about the analog input. So we have the same information on the previous slide, is 0 to 10 volts DC. And the other interesting thing is regarding the analog digital conversion, because the analog input will be receive analog signal and then we'll convert this for digital. So for this case, this smart relay Zelio use 8-bit analog conversion. So this means that the values of the 8-bit will be between 0 to until to 255. Okay, so maximum value with 10 volts will be 255 and the minimum value of 0 volts will be 0. Okay, this is the digital conversion. So this is the where we can connect, okay, IB to IG, okay, and then here's this information regarding the type of the input that we could be used. So for this specific case, we will use a potentiometer. Okay, here is the schematic how to make the connection. As you can see, we have the power supply here. Then we have the positive here connect to the one terminal of the extreme terminal of the potentiometer. And for the negative of the power supply, the 0 volts, we have in the other extreme of the potentiometer, the 0 volts connected, the negative. And in the middle, we have the analog input of the Zelio connected to the input IB here, in this case here, okay? So this is the scheme how to connect the potentiometer. As you can see, is the same that we can see here. So we have the positive in one extreme and the negative other extreme, and the middle we have the analog input connection in the Zelio Logic Smart Relay. Moving on for the software side. So there is a tool to program and simulate the smart relay. The tool is Zelio Soft tool. So with this programming software, it's possible to make all the programming and as well the simulation. So to show how to do this analog input connection with the potentiometer, I will show how to make this happen in the software side. using the Zelio Soft tool. Okay, so basically let's start, open the software. Okay, so starting the software, I'm using the version 5.4.2. The software doesn't have any cost, so you can download. So basically let's start a new program. Okay, here we need to select which will be the model of the smart relay that we're gonna use. So I will use this model with more IOs, with 26 IOs. Okay, so here we can see details about the inputs that we gonna have, right? So basically, as we show previously, we have the VDC and VAC. So for the VAC connection, we don't have any analog input available. So let's pick this one with 24 VDC, okay, with the discrete output by relay modules. Okay, so then we click advance, and then we don't want to add any additional module, so advance, and then ladder. The language for programming could be ladder or function block description. In this case, let's select ladder. Okay, and then we can see the initial screen with all the space for make the programming. So basically the first thing that we're gonna see is regarding for the analog comparators, right? So as you can see in this button here, we can open the analog comparators here. We have A1 until AG. It means that we have 16 comparators that can be used in the program. So let's move for the program. So here now let's click for the analogs. So we select A1 and press and hold and drop here, A1. Then with double click we can see regarding the parameters, right? So the parameters, when we make the double click, we can see here all the details of the comparison, right? So basically in the screen we can see the expression, the operators, and the analog input, the reference value or the reference value. So in this S standard we have the reference value is not select any analog input, and the reference value as well is 0. Okay, so let's go to the software and then we select one analog input. So let's select IB is the first analog input of the controller. Then we can see that the expression change for IB equal to 0. So now let's change for more or equal, greater and equal. So then we can see that the expression changes again. And then the reference value is value 2, means that is 0 here. So that's why we have this value here, greater or equal than reference value, that is 0. So let's change for 1, okay? So let's change 1 and then press OK. Okay, let's move for the presentation. So we have here, we have IC instead of IB. Let's change for IC, double click, and then let's change to IC to make exactly as the presentation. Okay, so once the parameter is already selected, let's make the connections. So to make the connections, we just need to proceed with the single click in the rung to make the connections. So one click here, one click here, one click here, until the last rectangle that will be coiled, this will become empty, and then we need to add a coil. Coil is just the Q So let's add Q1. Okay, let's check for Q1. The coil will be the standard one. So let's drag and drop. So we already have the Q1 in the place, correct? Okay, so let's go to the presentation, and then I already drag and drop. Okay, Q1 is in the place. And then now we need to change for simulation mode. So because for make the additions and change the parameters and make the connections in the ladder, so we need to use the edit mode. So to simulate, we need to change the edit mode to simulate mode. So for do this, we need to press this button here. So now we are in simulation mode. In simulation mode, it's not possible to change any parameter, right? So even the lines is not possible to delete or make any change in the program. So when we move for simulation mode, as you can see, we need now put the controller in run mode, the simulation software in run mode, because for now we are in stop mode. So to make the program start, we need to change for run. So once we press to run, so the circle change to green, and then we have the execution of the program, right? So as you can see, the first part of the line is in red, means that is energized, means that is true. And then to make this contact become true, we need to proceed with the expression. So the expression say that the analog input should be more than 1 volt, okay? So let's move for the presentation. So to make this simulation of the analog input of IC, we need to click in this button here in the bottom of the screen. So this is analog input buttons to simulate. Okay, so let's move to the software, and then let's click here. We have IC available, right? And then let's move, click, hold, and move for the right. So this is increase the voltage of IC until we have 1 volt. So as per our expression, when is more or equal to 1 volt, we have the contact make true, means that the contact close, and then we have all the line energized, and as a result we have Q1 energized. Okay, so now we can see that this simulation and software programmed is working perfectly. So let's try to increase to see if any change. So this is keep the line true, so means that keep the key 1 energized. Okay, and now let's reduce. Let's click, hold, and move anti-clockwise, and then we can see when it's less than 1 volt, we can see that the output of Q1 become de-energized, means that goes to 0. Okay, so there is one thing more that I would like to show. So here we can see that the line is complete in red, means that the line is energized. And here we have the option to make the comparison between two analog inputs, okay? So this is the comparison between IB and IC analog inputs. So let's move to the addition mode. First let's stop and then go to edit mode. And here, let's click here. Instead of use reference value, let's use IC. Okay, let's use IC, and let's put IB less than IC. Okay, so IB less than IC. IB less than IC. Okay, IB less than IC. So now we have two analog inputs. So when the first analog input is less than the second one, we have the contact A1 close and then the energize of the key one. Okay. So let's move to the simulation. So as you can see, now we have two analog inputs to simulate. We have two potentiometer to simulate here. And then let's click and run. Okay. So now we have both equals. So IC need to be more than IB. So then this is became true. So that's why happened right now. IC is more than IB. However, if IB increase more than IC, we have the energize of A1, and then as per consequence, we have Q1 de-energized. So let's move IB for less than 0.9 volts, and then we have again the close of the contact 1, the energization of the contact, and then the energization of Q1. So the output becomes true. Okay. So this is the comparison between two analog inputs. So as you show it to you, there is two analog inputs displayed when we change for simulation. Okay. And for this video, I think that I present everything related to the software. Hope that you enjoy, and subscribe to the channel for more videos like this one. And if you have any doubt, put in the comments and I will try to reply to you. Okay? Thank you. See you soon.